Welcome back, everybody. This is going to be me working out the example problem for our molar mass of compounds example. This was in the notes. We've got lithium chloride and magnesium nitrate were our two examples. You can ignore this. This was from an earlier take where my camera was not in focus. So I'm going to give you a moment. I would like you to pause the video and try to translate these names into formulas. You are going to have to be able to do that, so I would really recommend that you try that on your own first. It's a skill that you should hopefully be pretty good at by now. I think that was enough of me giving you a chance to actually figure out what it is by talking, so I'm going to assume that you guys have it for now. So lithium is Li on the periodic table, and then chloride, "ide" is the ending that it changes to whenever it's a ion or it's attached to something in a compound, so this is chlorine, so that's Cl. Li has a charge of +1 because of its position on the table, and chlorine has a position of -1 because of its position on the table, or 1 minus 1 plus. If we cross our charges, we should get LiCl for lithium chloride. Magnesium nitrate's a little bit tougher. Magnesium is Mg. It's got a 2+ charge. Nitrate is because it has the 8 ending there. If it was an ide, it would just be nitrogen, but nitrate means that it's a polyatomic. In this case, it is NO3 with a 1- charge. And if we cross our charges, we will get Mg. Make sure you put the parentheses and do NO3 2. You don't want to do NO3 2 like this, because this is nitrogen with 32 oxygens attached to it. That is definitely not what we're looking for. So you do not want to do that. So we're just going to box our answer. Now, this was something that you should have been able to do up to this point, but now we're going to actually try to figure out the molar mass of these things. Now, there's a couple ways you can set this up. I probably would not use this method now, the method I'm going to show you, because I've done this for so long that I'm confident in just plugging it into my calculator correctly. But this is a very strategic and methodical approach to figuring out the mass of the compound. And so it kind of details everything, shows all of the work very clearly. It's a lot easy for me to give partial credit for things when you do this. So we're going to use that method. So what I like to do first is I like to list out all of the elements that are involved. So Li and Cl. Those are my elements that are involved. And we're going to do LiCl first. I'll come back and I'll do the Mg over here in a little bit. Okay. And then I like to figure out how many of them that I have. So I only have one Li. There's an invisible one here. There's an invisible one here. So I've got one of each of those. And then because molar mass of a compound is just the masses of all of the pieces, there is one lithium. If you go to your periodic table, lithium weighs 6.94, and chlorine weighs 35.45. Well, since these are both 1 times, that's pretty easy. 6.94, 35.45. And then all we have to do is just add all of our pieces together, and we have 42.39, and that's our answer. We've got it. We figured out what it is. Make sure you write your answer in units. We don't have to care about sig figs for this because all numbers that come from the periodic table go to 2 decimal places. This multiplication here, this was not a measured value, so we don't care about sig figs. We added these two things together. Addition rules state you go to the lowest number of decimal places. They both have 2 decimal places, so don't worry about rounding or anything like this. All of these numbers will go to 2 decimal places. But we do need to care about units. So the units for this number was a grams, and this number was a grams. Because that's kind of what we've been using it for. Or it could have been an AMU and an AMU. But in this case specifically, we were trying to find the molar mass. And molar mass is always in units of grams per mole. So this number here is actually 42.39 grams per mole. In 1 mole, in 6.02 times 10 to the 23rd particles of lithium chloride, if you had 6.02 times 10 to the 23rd of this ionic compound here, it would weigh 42.39 grams. Every 1 mole is 42.39 grams. Okay, that one's pretty straightforward. The next one is a little bit more complicated, but it's the type of math that you guys should still feel pretty comfortable with. So we're going to do the same approach. We're going to list out. We've got mg. If you aren't super worried about space here, you could just crunch these all together. But I'm going to do it separated out so it's a little easier to see. So we've got mg, n, and we've got o. For mg's, I've got 1. For n's, I've got a 2 times this 1 nitrogen. So that's going to be a 2. And then this oxygen is going to be, there's 3 of them times 2, so that's 6. Then we just go to the periodic table. Mg has a mass of 24.31. Nitrogen has a mass of 14.01. Oxygen has a mass of 16.00. And in case you're like, oh my god, Diamond's so good at this, I'm working out all these ahead of time, but I do know some of these. I do have these like memorized, but I do not have all of these random numbers memorized. I just worked them out in advance, so peek behind the curtain there, so ruin the movie magic a little. So this is just 1 times, so 24.31. It's nothing too crazy there. This one you could probably do in your head. You get 28.02. This one you might also be able to do in your head, but you have your calculator. You might as well plug in your calculator. 6 times 16 gives you 96. And then we add all of these pieces together. You could try to do this in your head, but again, you've got a calculator. You might as well use it. You get 148.33. But again, we need to make sure we have this in the proper units. So it's a molar mass, so this is going to be grams per mole. So our answer is 148.33 grams per mole. So that is how you calculate molar mass of compounds. This is a skill that is pretty important for you to be able to do. Molar mass is going to allow us to convert into moles, and as we talked about in the notes, moles is like the key or the gateway to actually being able to do all of these types of problems. So make sure that you feel comfortable with this. On Monday, actually probably sometime this weekend I'll post it, but by Monday there will be a video or a worksheet for you to work on that's all just calculating a whole bunch of molar masses. So I hope that makes sense to you. If you have any questions, as always, feel free to email me or write them in the comments in the box below or to the side. Thank you all for watching. Hope you guys have a great rest of your day.